Okay. First of all, I'm starting with SVN. After SVN, we will move to Git. Okay. Both are version control systems. Now we will see this. Let me show you a few slides. Okay. Version control system. This is, as I said yesterday, version control system is nothing but code repository which saves your code in centralized repository. Okay. Uh, Here we use Visual SVN as a server and Tortoise SVN as a client. Okay, this acts as a server client model. In all your code will be pushed by Tortoise SVN to Visual SVN server repository. There we maintain code in different versions. Each change will be saved as a separate version. That means, see, for example, you have made 10 changes to your code. Okay, while you are developing, you have done 10 changes. That means you are adding more code or editing or changing anything and committing each time you change the code. So each time there is a change, this version control system will be saved as a different version. Say after 10 commits, you found that there is something happened, then you can revert it back to 8th or 7th, which is the better version. Okay, I think if you are a system administrator, you know a restore point in Windows, right? So you will go back to best configuration or best known configuration of your machine if something happened to your machine. So that is how, just remember that you have separate version for each change you make. Okay, we will see practically, and those changes will be saved in a centralized repository. Okay, let us discuss a few more things on this. Now, see this. Remember this. Visual SVN is a server software which you have to install on your centralized repository, centralized server where you want to maintain this Visual SVN server, and all your developers will have Tortoise SVN on their Windows machine. Tortoise SVN for SVN is for Windows, and Rabbit VCS is there, another client. You can use that one as well, but that is for Linux desktop machines. Rabbit VCS. Okay, fine. We will see normally how this version control system works. For example, say Harry and Sally both are your developers. Okay, and I have a code repository and I have file A. Okay, see, remember this terminology. Whenever you are pushing your code to repository, that is called committing. Okay, whenever you are uh, taking the code from repository to your machine, that is called checking out. Okay, when you say someone, I checked out the code, that means he got the code from the repository to local machine. Okay, I use these terms now. Committing is copying to your machine, and sorry, committing is copying to repository from your local machine, and checking out is copying from repository to your local machine. Okay, now I use these terms. First of all, this in repository there is a file A. Okay, file version A, for example. Now Harry and Sally both, in the first diagram, let me point out, in this diagram, Harry and Sally both checked out the code to their local machine. Okay, then what they did is, here you can see a single quote. Harry changed some modification, and Sally a double quotes. Okay, notice this, a double quotes. So they made changes on both files. For example, now forget about the SVN, normal file. Take it as a normal file. Forget about version control system for now. Okay. Now what happens is, Harry made some changes and Sally made some changes. Okay, both are different. Then now, um, Harry writes his changes to repository. Now in repository the file changed to a single quote, right? Then Sally also write the same changes to this repository. What will happen normally in normal cases? All the changes will be overwritten. All the changes made by Harry will be overwritten here. That is what happens, right? You know that. Let me explain you again. Both both the people took the copy of the same file from the repository and they made their own changes. First Harry wrote the same changes to repository file and later Sally wrote this. But Sally's changes will be overwritten. Sorry, Harry's changes will be overwritten by Sally's changes. Right. So this is the normal scenario. But later people came to another development on this called locking system. Then what people were doing is first Harry copied the file from the repository to his local machine, and then he locked the repository. So sorry, he locked the file in the repository and made the changes. Okay, and at the same time, Sally wants to write on this file, but it doesn't happen because this file is locked. Okay, unless Harry unlocks it, Sally cannot do anything on this file. Okay, fine. Harry wrote his changes, a quote, and unlocked the file. Then Sally has to read the file, but what Sally reads is whatever changes made by Harry will be seen here for Sally. You got my point, right? If you are not understanding or confused, please let me know. Okay, I'll explain right away. So here this is the lock system. Okay, and Harry reads the file and locks it because whatever he makes the changes will not be overridden by anybody else, or he doesn't want anybody to interrupt his work. At the same time, Sally cannot uh, make any changes or read the file. She may read but she cannot write, okay, because it is locked. Then Harry made the changes and wrote in the repository. Then Sally got the new version, a quote, but not a. Okay, and she locks it until she finishes her work. But in normal scenario, we are not sure how long these people lock that file. For example, say I locked the file and I lost my internet connectivity, for example, but the file will be locked forever unless I unlock it. And people nowadays are working from different geographical area. One is from US and for example one is from India, and someone locks and goes away and another people cannot work on the same file. And moreover, if Sally and Harry has say, I mean, work and ascend for a day, and Harry takes entire day for locking the file, and Sally cannot do anything, so people has to wait for that. But people lose the productivity, right? In that case, this model doesn't work. Okay, so now you see this. Now what happens is, oh, just a moment. Yeah, two users copy the same file and make their own changes. And if someone, for example here in the third picture, Sally writes her changes to repository, and whenever Harry commits the file, it doesn't work because the copy which Harry took was outdated. Okay, but of if Harry commits this file, and all the changes done by Sally will be overwritten. Okay, so now we'll see where this version control system comes to picture. Okay, here it is. What happens is, already in previous picture, see here, let me show you previous slide. In previous slide, Sally already made her changes. Okay, made her changes, a double quote, and Harry made his changes, but he has not committed yet because the change is already done by Sally and it is saying that write denied. Right. In that case, what we will do is, in that case, he has to read the file again. It says Sally already committed, so whatever the version you have in your local machine is not updated because the actual file in the repository has already been updated by Sally. So what this man Harry should do is he has to update that file. So he has both A1, a quote, a single quote and a double quote, both the changes. So now he has all the file, right? His changes and whatever done by Sally. And then it becomes star. For example, this star has all the changes made by Harry and Sally. Then he commits the code to repository. Then Sally will have, when Sally updates his file, Sally will have both the changes made by uh, Harry and Sally. You got my point? So this is the advantage of version control system. So whoever is working in different locations and working on the same file at a time. So this is the simple thing. Let me summarize this. For example, forget about these pictures. What happens is there are two guys who are working on the same file. Okay, in normal situation, if you don't have any version control system, what happens is whoever saves the file first will be saved. Okay, if the second person saves again, the first person's work will be lost and second person's will be overwritten by that. Okay, to address this problem, what these people are doing is they are using version control system. So without overwriting anyone's work, simultaneously people can work and commit their code to repositories. All the code will be saved in repositories. Remember this, in software industry there are centralized version control system code repositories where people will save all the code at one place. Okay, people will not write code and save it on their own machines. They maintain own code repositories and they take backup of that code repositories. Okay, like that. Okay, first of all, let me tell you one more thing with theory, and we will go to installation part and check that. Okay, so in code repository, what will happen? Let me. You will not understand now. Let me try to install it and tell you. Okay, so you can download Visual SVN for free. You have to download two things: Visual SVN and Tortoise SVN. Tortoise SVN is a client and Visual SVN is server application. See, for example, yes. So this is the page. I'm pinging both the links for you. And this is Tortoise SVN. Okay, so it depends on your system's bit architecture, whether it is 32-bit or 64-bit. You can simply download the version you want. So how to check that? Remember that Visual SVN server is only for Windows operating system. You cannot do that in Linux. Okay, for Linux there is another server, CollabNet. You can try that. Okay, and if you have Git will work on both Windows and Linux. Okay, see how to check your bit version means go right click on your computer and go to properties, and here you can see the bit version of the operating system. Okay, this is how you have to check your bit version. Okay, fine. I think most of you know this. Now you have to download this both. I have already downloaded on my server this one. Let me install it. I have 32-bit version, so I downloaded 32 version. Installation is very easy. You have to accept the terms and conditions and go with administrative tool default options. Okay, here you have standard and enterprise edition. Okay, you have, if you want to go for enterprise edition, you have to enter license, but I'm not using right now. I don't have any enterprise license, so I'm using this repository standard one. Okay, standard edition. See here, this location is where you are going to install your SVN server, and this is where you save your repository. Where I am saving is in D. I have repositories. Yeah, I have already repositories. Let me create one new folder and give it repo. So I choose that one. Sorry. Mm, yeah, this is repo. So normally what happens is in your real-time environment, your code repository will be huge in size. Might be in TBs also. Depends on your code. Normally it would be more than TB. So in that case, what you have to do is, if you have any external drive, for example, if you are using AWS or any physical machine, you have to keep any external drive so that you can mirror it or take snapshots for backups, etc. Okay, that is a best practice. And here you can use, these are the two ports. HTTP, for HTTPS, it is a secured HTTP. This port number uses that, so better you keep this 443. If you want to have any custom port, you can also give that. Okay, I'm keeping it as a default. See here, it is showing here as HTTPS. So remember, you have to be more clear about your ports. Okay, which port is being used for which purpose. HTTP3 is for HTTPS. You see here, this side uses HTTPS. That means it is a secured connection. Okay, normal website uses 80 port. Okay, port number, remembering port numbers are very good practice, because you will be asked in interviews, and whenever you are going to work right with AWS security groups, you need to understand which port is used for what purpose. Okay, right now I'm selecting my new folder here. In real time, you have to select your new drive for repositories if you are provisioning provisioning the Visual SVN server from the scratch. Okay, fine. Next, install. It doesn't take much time. Okay, let it be. And one more thing is, this Tortoise SVN, you can also install as per your bit version, the latest one. I already have installed it, so Tortoise SVN, sorry, Tortoise SVN. I already have installed, so I'm not showing the installation part because it's very easy. Okay, it doesn't take much time for you as well. Okay, fine. So my installation is completed. This is how it looks. Okay, this is how it looks. Normally you have repositories. You can have multiple repositories here. So for example, you are SVN administrator and you are supporting for multiple projects. So for each project you create a different repository. Okay, if you have multiple clients, for each client you create different repositories, because the code would be different for each project. And you create users and groups and give the permissions as per their responsibilities. Okay, let me show you how to create users and repositories today, and tomorrow we are going to discuss more about how it works. Okay, see, you have to right click on this repository icon and create new repository, right? So a regular FSFS repository and VDFS, these are the different types of this is virtual disk file system, and FSFS is used by this Visual SVN. So I am going for regular FS. Okay, next. So here I have to give my repository name. For example, I am giving project 1. Project 1 is my client, for example. And next, empty repository and single project repository. Here you have to understand, empty repository will not have anything inside that. You have to create everything from scratch. That means this repository has a structure. So I'm going to select single project repository. Okay, uh, so it has three things. It has three things, as you see here: top level, trunk, branch, and tag. Okay, I'll explain you what is trunk, branch, and tag uh, in 5 minutes. Okay, for now we will create this. Okay, single project repository. Next, all Subversion users have read-write access. So this is where you need to select, but by default this option should not be selected by you. By default you have to select nobody has access, or you need to customize. Customize means here if you have users you can add. See, we don't have any users, we have not yet created any user, right? So this is not showing up any users. For now I am selecting all Subversion users for this repository. Okay, we will check other option, creating more repositories, no problem. So remember that whenever you are creating repository, don't give this option. If you give nobody, and you can allow access later, or if you have a set of users, you can simply give access to them right away here, and you can create the repository. Now I am selecting all Subversion users have read and write access. Creating, finish. So when I created, it gave one URL, right? Let me show you that URL. Oh, yeah, here you can see the URL. This is my project URL. I highlighted, right? Yeah, here it is. This is my URL. Normally in your situation, this is my laptop. So it is giving my host name and my domain name and SVN and project name. So in your real-time situation, whatever the host name of your domain name, your server, that would be in here, and you have to share this URL to your developers so that they can get the code from the repository and they can push the code to the repository. I'll show you how it happens. Okay, so now you can see here tags, branches, and trunk. Okay, what are these? So in normal software development, for example, the blue line indicates the trunk. Okay, this red line indicates the branch. Let me explain you. Okay, you see this arrow, right? So we start at 0 here at the starting. Here it is 0. Okay, and our development is going on this way. So first of all, I give my trunk URL to my developers. What they will do is they will start working on trunk. Okay, they'll start working on trunk and continue the work. At this point, at tag they create tag 1.0 and they deploys the code into server. Deploys means they are running their code into server so that their clients will have the feature which they developed. Okay, so after this, normally what happens in software development is after releasing a tag for the first time or any time, it may have some bugs, or client says I don't want this and I want some improvement on this application or something like that. So for example, after deploying the tag 1.0, okay, this application failed at some point. I mean, there are few minor or major bugs. Then what happens is if 10 developers are working in trunk, after this point 6 people are working in for example 6 people are working it for next feature at tag 2.0 and 4 people will work here on branch for bug fixes. You got my point, right? So here I create another branch at this point in trunk. I create another branch 1.0. That means all the code in trunk at this point at tag 1.0 will come into branch 1.0, and we have the same in trunk. The horizontal line is trunk, the blue horizontal line is trunk. So here we have two copies, one is in branch and one is in tag at this point, right? One is in trunk and one is in branch. So four people will work on bug fixes and 6 people will work on next feature. So at this point at tag 2.0, these 6 people will have finished their work and these 4 people finished in the branch fixing the problems. So at that time they'll merge it to trunk again and create one tag. Okay, tag is a frozen state. After creating tag there will be no changes. Remember that. People may ask you in interviews like this, how do you commit to tag? Okay, we will not, we should not commit any changes to tag. Okay, we can commit, there is a possibility that we can commit to tags, but we don't. They will cross check you like have you ever committed code into tags, like that, but tell them that we should not commit code to tags. Okay, right. Tag is a frozen state. Once tag is created, it will be deployed to production or pre-production. But you can make changes in trunk and branches, but not tags. Remember that. Okay. So after fixing the bugs in branch 1.0 and after work, these 6 people completed the second feature. Okay. At this point, the branch would be merged to trunk so that the new feature and the bug fixes all are there. So at that point we have created one tag. Okay, so again after checking that tag this 2.0 may have some bugs. In that case we create another branch like 2.0 for bug fixes. We do the same cycle. Okay, this is the one of the branching strategy. Okay, there are so many, but all are confusing ones. You can create branches from the branches if your application is more complex, or you can have more branches at a time like this. You can have more branches at a time like this. For example, 1.0 is very complex and 4 people are working for some bug fixes and another 2 people are working for some other modifications like that, and You can merge like this as well. There are so many branching structures, but the clean one is this. You can remember this. Right now, with your knowledge, when you are going to any interviews, remember this structure. Nothing else is required. Many organizations uses this branching structure. Okay, the main code pipeline will continue on trunk. Okay, and from each tag, after each tag, they will create a new branch for bug fixes and any changes, and other people will continue their work on the trunk itself. At the next release, after fixing the bugs in branches, they merge it to trunk and create tag and deploys it in the production environment. You got my point, right? So please let me know if you have any questions or any doubts till now, so that we can move ahead. Please ping me or speak out. This is not more complex technology. Okay, this is, you are just creating simple structure. Looking at this diagram, you need to understand how it is being created. The first step is trunk and branching and tagging, nothing else. Okay. uh, okay, fine. If you have any questions, please interrupt me. Now what you will do is, now um, let me check out this. See, copy this URL. Normally you have to give the trunk URL to your developers. Now what I'm doing is, I'm right clicking on trunk and copying URL to clipboard. Okay, so I don't have any users now. Let me create one user for myself. So users, create user. So I'm creating my user. Mm, See here, username and passwords are case sensitive. That means if you use uppercase, you have to use uppercase, or lowercase letter would be lowercase. So you have to be more careful while creating users. Okay, so one user got created here. Let me check this. Yeah, one user got created. His name is Jay. Now what I'll do is, I'll create one directory in my local machine code. Okay, in this directory, what I'll do is, I'll right click. If you have SVN installed, you will get these two options, SVN checkout and Tortoise SVN. My first thing is, I have to check out. There is nothing in the repository, but I have to check out. Checking out is copying that. Whenever I hit checkout, it gives me this. But my repository URL is this. Just a copy. Sorry. I got this URL. Let me copy it again. The trunk URL, copy. I have to paste here. Okay, I paste. In this, I create my project. Okay. So we will check other options in later classes. Here we have head version, show logs, etc. Right? Fully recursive, depth, etc. So we will look into that in later classes. So for now, I am giving my SVN URL, and I am giving the location where I need to check out the code. Now I got some error, unable to connect to the repository URL trunk. The request name is invalid. So yes, I got it. So actually what happened is, my SVN my SVN has already my other credentials. Now it didn't ask any credentials, right? So in order to change my credentials, you have to go to your user profile, and tortoise SVN. This log file saves all my details. Okay, so what I'm doing is I'm deleting this. So now whenever I check that, remember it might be your troubleshooting tip. Okay, under users, your username, app data, local. Inside that you have all the applications. My passwords will be saved here by default. If you hit remember password, then I go to my directory and check out and hit OK. Oh, why is it not asking for login? Give me a second. Yeah, here I have to remove my this thing. Here I have all the files in my roaming profile. Okay, let me check once again. No, it is not asking for the servers. Give me a second, guys. Actually, this is my office laptop, and I have other configurations as well, so it is conflicting somewhere. Okay, let it be for now. Um, I'll check that and I'll install again. Uh, because this is office system, right? I'll connect from my own system from tomorrow. Okay, anyways, so this is the structure you have to follow, and I want you all to install both Visual SVN and Tortoise SVN ready. Okay, and once it is done, we can simply work on this. Okay, what you have to do for tomorrow is um, try to install this SVN, Visual SVN and Tortoise SVN, and create one project and create one user, and we will continue from tomorrow onwards. Okay, if you have any doubts, please let me know so that I'll explain. Anybody has any doubts, or you think you did not understand anything, please let me know. I think by now everyone should be more clear that why we are using um, Visual SVN server, why we are using Subversion. Okay, please let me know if you have any doubts. Ping me on WhatsApp, or let me share you my email address as well so that you can connect with me. This is my email. You can write emails or ask any doubts whenever you have something. Okay, so I want you to install by yourself and troubleshoot wherever you are finding some difficulties, because you need to understand other boards as well. Okay, what's the architecture type, how you install it, how you uninstall it, where you are saving the repository, everything should be in your mind, because these are very important for your interview purpose. Okay, we will continue tomorrow then, if you have and if you have no doubts. Okay, thank you for your time.